Lesson 4.8. Use the quadratic formula and the discriminant. Completing the square was a long, laborious process. Today we can develop a method to make it much quicker. We'll do it by completing the square, but in variable form. So ax squared plus bx plus c equals 0. Move c to the other side, and then divide by a, so we have 1x squared. Then I can add 1/2 of the middle term squared. Well, 1/2 of b over a. So 1/2 of b over a is b over 2a. Add that to both sides. I can write the left-hand side as a perfect square. So I have x plus b over 2a squared. Here, b squared 4a squared. I need a common denominator, so here, because the denominator is 4a squared, I multiplied this by 4a. So 4a and 4a squared. I can combine the fractions, so it's b squared minus 4ac on the top, and then take a square root. So as I take a square root, don't forget the plus and minus. So it's the square root of the things on top over the square root of the bottom. Conveniently, the bottom's a perfect square. 2a. Square root of 4 is 2. Square root of a squared is a. And then I can combine this into a single fraction. Ta-da! I have now solved for x. It's called the quadratic formula and always works to solve quadratic equations. All you have to do is fill in a, b, and c. It even finds the complex solutions. The part under the square root is called the discriminant, and it tells you what kind of solutions you're going to have. If b squared minus 4ac, the discriminant is greater than 0, taking the square root of that, you get 2 real solutions. If the discriminant is 0, we have exactly 1 real solution. It's called a double solution, and that would be negative b over 2a. That sounds familiar from way back. That's where the vertex is. If our discriminant is less than 0, you get 2 distinct imaginary solutions, because you're taking a square root of a negative number. So what types of solutions do we have here? Since it's asking for the types of solutions, we'll find the discriminant. Remember, that was b squared minus 4ac, the part under the square root in the quadratic formula. b is 3, a is 5, c is negative 4. Fill those in. And you get 89. 89 is larger than 0. Since it's greater than 0, it's positive, we'll have 2 distinct real solutions, or real roots. So now let's solve this. We set it up so it equals 0. So we move the 4 over to the other side so it equals 0. Then we need to fill in the quadratic formula. b is 3. b is 3. a is 5. c is negative 4. Then we simplify that. And you get negative 3 plus or minus the square root of 89 all over 10. We cannot simplify the square root of 89, so that is our answer. Now let's try to solve this one. Use the quadratic formula. A is 4, B is negative 6, C is 3. Simplify. Negative 6 squared is 36, and 4 times 4 is 16 times 3 is 48. 36 minus 48 is negative 12. Negative 12 is square root of 4, square root of 3, square root of negative 1. Square root of 4 is 2, square root of negative 1 is I. Since it's complex, let's split it up into two separate fractions. So we have the A plus BI. So let's split it. And then reduce. 6 over 8 is 3/4. 2 over 8 is 1/4. Looks like that's all you get to do today.